Hello friends, good evening. Welcome back to Wallah English YouTube channel. I hope everyone is doing great. So first everyone kindly comment that I'm fully audible and visible to you all. After that we'll begin our lecture. So till yesterday we have discussed the basics of hydrology. We have discussed the introduction part in which we have covered your water cycle and some basic terminology such as what is your catchment area, what is global water distribution, and how your water is distributed on your planet Earth, that we have discussed in yesterday's class. Okay, so I hope you have liked the yesterday's sessions, and today we'll continue further. Okay, so everyone kindly comment if I'm fully audible and visible to you all, then we'll proceed further. Okay, so what we have covered till yesterday. So till yesterday, let me have a quick recap, after which I will proceed. So till in the last class, firstly we have discussed the basic topics. Okay, all the topics which we are going to cover in your hydrology, that we have discussed. So these were the topics which we have to discuss one by one. So firstly we are discussing introduction to hydrology. Okay, in introduction part we have discussed the water cycle, and today we are going to cover your water budget equation. Okay, so after that we will proceed to precipitation, abstraction from precipitation. These are the subsequent chapters which will deal later. Okay, I told you that precipitation and abstraction from precipitation and hydrograph part is very important for from your GATE point of view. Be it GATE, be it engineering services, or be it any other state exams, these chapters are very important for you all. Okay, so firstly we have discussed what is hydrology and why we are studying it, and what is the basic sense. Okay, we have discussed that we are interested in estimating the water resources, and we have to solve the problem of shortage of water and when water is in excess, namely drought and floods. Okay, I told you that we have to discuss, we have to combat them, we have to mitigate them, that I have already told you yesterday. And how much is the total rainfall that is being received by your Indian subcontinent? It's nothing but 4000 bcm or 4000 kilometer cube. I hope you all remember this. Good evening dear, good evening everyone. Good evening. Okay, ISRO is easy to clear written, sir. Yes, everything is easy when you will work hard. Okay, yes dear, if you are scoring more than 220, then obviously you can go for mains. There are chances that you may not get selected, but still if you are preparing for mains you will get the experience. Okay, so I told you this is amount of rainfall which is being received by Indian subcontinent, and this is the total water resources of your India after this is being lost in evaporation form. I have told you this. So out of this 1850, only 1200 kilometer cube can be utilized, remaining is getting lost. Okay, total water in the world is how much? 1386 million kilometer cube, or you can simply say 1400 million kilometer cube. Okay, I have told you this already. Then I told you that total 97% water is in oceanic form, or you can say saline form, and remaining 3% is fresh water, out of which mostly 70% you can say is in frozen form, and remaining 30% is in the form of groundwater. Okay, and some 1 or 2% is in surface and other resources. Okay, and that too majorly in lakes. Most of the surface water is in form of lakes. Then I told you about the water cycle, the hydrological cycle. Okay, the hydrological cycle. Okay, we have discussed all the parts. The first one was evaporation, then precipitation, and after all the losses takes place, we are left with the runoff. Okay, ultimately all the water which runs off ultimately reaches your river only. Okay, so this was the beautiful diagram which I have drawn here. I told you yesterday about the hydrological cycle. Let me ask you a very simple question. Everyone try to comment. Okay, let me ask you a very simple question. So the question is, can you tell me what is the driving force? Can you tell me what is the driving force behind, behind, you can say behind this water cycle? Can you tell me? If someone asks you like what is the cause of this water cycle, can you tell me what is the answer? Yes or no? Yes dear, in Ashoka batch I will be dealing basically with three subjects. Okay, one is your highway which you are saying, next one is your environmental engineering, and one is your hydrology irrigation. Okay, so these three I am teaching there. Remaining subjects will be taught by another faculty, so no need to worry. Okay, so I hope this is clear to you all. Yes, you are right. The cycle, this cycle is being driven by sun's energy. Okay, if someone asks you like what is the cause, what is the cause behind this water cycle, so we can simply say the cause behind this water cycle is nothing but the sun's energy. Okay, so if someone asks you what is the cause of this uh, water cycle, it is a sun driven process. I already told you yesterday, it is a global sun driven process. Why sun driven? Because of the energy of sun, this process is being circulated. Water is being transported from one phase to another, and then from another to the next one. Okay, like that. So water is being transported in from one phase to another with the help of the sun energy. Without sun's energy, you will see that there is no water cycle. Okay, so sun's energy is the basic cause, you can say. Many other factors are also there, but the sun's energy is the basic one that you need to remember. Then we discussed all precipitation. What is precipitation? What is evaporation, transpiration, interception, percolation, infiltration, runoff, varga, everything we discussed. And at last, I told you about the catchment area. Catchment area is also known as watershed. It is also known as you can say basin, or it is also known as sink, in which, see, it is a area, it is a area in which whenever rainfall is there, it will ultimately drain off to the main river. Whatever water is falling in this area will reach your main river. Yes or no? This is your valley line, and the valley line is you can say is the lowest line where your river flows. I gave you the example of this Gangetic basin, okay, in which all the water which is falling here in the form of rain ultimately drains off into the river Ganga. Okay, so this is your huge catchment area of river Ganga, very huge catchment area, and this entire catchment area can be divided into very small subcontinents. I had already told you yesterday. Okay, so I hope this part was very clear to you. So catchment area is very important. This you have to remember. I hope this is clear to you. So this was catchment area. So catchment area, whatever water falls in the catchment area comes off ultimately into the valley line, or you can say the river, which is at the lowest level. Okay, see, if water is falling at the ridge means the highest point, it has two options. It can either go into this catchment area, or it can either go into this catchment area. Yes or no? So if you see, this is the ridge line, or you can say it is the highest point. Okay, if I want to show you it in the diagram, then you can see this line. This line is your ridge line. Okay, whatever water falls here, it has two options. It can go either into this catchment area, or it can go into another catchment area. Okay, so entire Indian subcontinent is divided into many small catchment areas. Okay, so catchment area concept is very important when it comes to hydrology, because whatever water budget we will apply it to catchment area only. So I hope catchment area term is fully clear to you all. Yes or no? Kindly comment everyone if this concept is fully clear to you. Yes or no? Okay dear, I will try, but many other faculties are also there, so that is also the case, so we have to take it. Okay, so now we'll start our today's lecture. Okay, yesterday's lecture I have gave you the entire concept in brief. Now today we will basically study water budget equation. Okay, like what water budget equation is, and we will also solve some questions. Okay, we will also solve questions simultaneously in the class, so that you get the full idea. Okay, so now let us start about the water budget. So before starting water budget, first let us discuss about catchment leakage. Okay, let us discuss about catchment leakage. See, catchment leakage is a very simple concept. You need to understand one thing. See, understand, look here very carefully. See, this is your let us say this is your land mass. Let us take two examples. Okay, let us try to understand it. So let us take two land masses. Okay, this is your first land mass, this is your second land mass. Okay sir, understood. Now this is your surface, and below the surface we have groundwater. Yes or no? Below the surface we have groundwater. Yes or no? So let me draw that also. See, let me draw it here also. Let me draw groundwater here also. See, now what is the difference between these two cases? Listen very carefully. See, the difference between these two cases is, in the first case you can see that the surface's highest point is coinciding with the highest point of groundwater. Yes or no? See, these are in same line. This is very important. Okay, see, if you want to understand the concept of catchment leakage, you have to understand that highest point of surface and highest point of groundwater are coinciding with each other? Yes or no? Highest point of ground and highest point of groundwater. Okay, highest point on surface and highest point on groundwater are coinciding with each other. But here in the second case, you can see that it is not coinciding. It is not coinciding. You can see that uh, ground, or you can say surface, highest point is here, but groundwater top point is here. Yes or no? So they are not coinciding, they are not lying in the same line. Yes or no? Here, so we have two cases. Now sir, what will be the difference? What will be the difference in both the cases? Can you tell me? See, this is the highest point, this is the ridge line. Whatever water will fall, you can say on the right side, on the right side of this line will be going, or you can say that water will be flowing into this catchment area, and the water which will be falling on the left side will be going into the left catchment area. Yes or no? Yes or no? So let me show you with the help of a diagram. Let us say water is falling here. Okay, let us say water is falling here. It will go, some water will go inside the ground also, then it will flow. Some water will reach your groundwater and then it will flow. But ultimately whatever water is falling on the right side is flowing into the right catchment area. Yes or no? And whatever water is falling, on the left side, and whatever water is falling on the left side is going into the left catchment area. Yes or no? So whatever water is flowing here, or you can say falling here, is going into the right side, and whatever water is falling on the left side is going into the left catchment area. Yes or no? But the one basic point is here, one basic point which you have to remember is that surface, the surface highest point, or you can say surface divide, surface divide means the highest point. The surface divide means the highest point. Okay, highest point which is dividing the land mass into two catchment area. One is this catchment and one is this catchment. Yes or no? So surface divide and groundwater divide here, surface divide and groundwater divide means the topmost point of surface and the topmost point of groundwater, topmost point of surface and topmost point of groundwater are coinciding, are in line. Yes or no? Are coinciding, are coinciding. Yes or no? But in this case you can see that surface topmost point and groundwater topmost point are not in one line. Yes or no? Yes or no? Can you understand this? So I will say here one more point, that surface divide and groundwater divide are not coinciding, sir. Here are not coinciding. Surface divide and groundwater divide are not coinciding, sir. Are not coinciding. Yes or no? Now sir, if they are coinciding and if they are not coinciding, so what is the basic difference? What difference it will make, sir? That I want to understand. So listen very carefully. See, now let me show you with the help of a diagrammatic explanation. Listen very carefully here. So let us assume that some water is falling here. Okay, it will go inside the earth's surface and it will flow here. Okay, yes or no? Like that, and it will also join your groundwater. Like that, it will flow here. Okay, in this fashion, water will go on the right side of the catchment area, or you can say it will go into the right catchment area. But let us assume some water is falling here. Let us assume some water is falling here, and obviously it will flow on the left part. But listen very carefully. When this water will come inside, when this water will come deep inside, it will join groundwater table. But you can see that some water, since groundwater divide is on the left side, you can see that some water will flow in the next catchment area, not in its own catchment area. See, here from here on the top surface, I will see that catchment is being divided from this point, right side, left side. But when this water will enter inside, you will see that some water of this catchment is leaking on the right catchment. Yes or no? Why? Because groundwater is not coinciding. Since this groundwater highest point is here, so some water which will reach inside, it will move on the right side. Yes or no? It will move on the right side. So this part is leaking. Yes or no? Sir, this part sir, this part is leaking, yes or no? You can say that this amount of water has fallen on the left side, but still, sir, it is going on the right side of catchment area. That's why we are saying catchment leakage is happening only when your surface divide and groundwater divide are not coinciding. Yes or no? I hope this is clear to you. But if they will coincide, whatever water will fall on the right side, it will be remaining in the right catchment area, and whatever water will fall on the left side, it will remain in the left catchment area. But if they are not coinciding, if the highest point of surface and highest point of groundwater does not coincide, then I will say in that case, catchment leakage will be there. In that case, catchment leakage will be there. Yes or no? It will be there. I hope this is clear to you. Everyone kindly comment. If you have understood this. Kindly comment yes or no in the comment box. If you want to ask it again, I can repeat it. Okay, everyone try to comment. Kindly comment, everyone. But in this case, when topmost point of surface and topmost point of groundwater are coinciding, then no leakage will be there. Whatever water is falling on the right side, it will be flowing into the right catchment area, and whatever water is falling on the left side, it will be flowing into the left catchment area. No water will leak. Water leaks only when your surface and groundwater are not in line, because water which will be reaching deep inside, or after percolating deep inside your earth, it will join groundwater and it will flow on the right side, or it will leak into the another catchment. See, this water has flowed into this catchment area, but still some water is leaking into the adjacent catchment area. That's why the term catchment leakage. So this amount of volume, or you can say this volume of water which is leaking into the other catchment, is termed as catchment leakage. Yes or no? Okay, understood? Very good, very good. I hope this is clear to you. Okay, so this is your catchment leakage. Okay, now we'll move to runoff coefficient. Runoff coefficient. What is runoff coefficient? See, runoff coefficient is a very simple term. Okay, many questions have been framed in GATE examination and engineering services examination related to runoff coefficient. Now we have to understand what is runoff coefficient. Okay, see, runoff means what? Runoff means what? Sir, after rainfall, whatever water, is getting lost, after that whatever water remains flows into the rivers, or you can say into the streams. That is runoff. That means runoff means what? So runoff means that some portion of rainfall, some portion of precipitation after rainfall is getting drained off into the main river. Or you can say, I told you already that in the center part of your catchment area we have one main river. Yes or no? I told you this thing. Yes or no? So you need to understand that some portion of rainfall ultimately drains off into the main central stream. So now if you want to understand what is runoff coefficient, see, runoff coefficient is nothing but it is the ratio. You can simply say it is the ratio. Let me write here. It is the ratio of runoff to the rainfall. It is the ratio of runoff to the rainfall. Okay, to the total rainfall. That means out of total rainfall, how much water has converted into runoff. Only some portion will be converted into runoff and some will be lost. Okay, so you need to understand this. So we will denote it with the letter C. C simply denotes runoff coefficient. If someone asks you like what is C, C is runoff coefficient, and it's very, very important. You need to remember it. Okay, we will solve one question also. Today only. So C is what? Runoff upon rainfall ratio. Runoff upon rainfall ratio. This you have to remember. Very, very important term. We'll discuss that later also. We'll solve some questions also. Let us take a very beautiful example so that you are able to understand it also. See, for example, just assume that in a certain area rainfall is 10 centimeter. Just assume it. Okay, sir, I have assumed it. Rainfall in a certain area is 10 centimeter. Let us take runoff as 4 centimeter. Okay, so out of this 10 centimeter rainfall, only 4 centimeter water has run off, and remaining 6, where it has gone, sir? See, remaining 6 centimeter has been lost in the form of evaporation, infiltration, or be it depression storage. It has been simply lost. Okay, many abstractions or many losses will happen from your precipitation. That we'll discuss in the third chapter, losses from precipitation. Okay, I've already told you that. So I hope this is clear to you. So sir, what you are saying, out of total 10 centimeter rainfall, 6 centimeters has been simply lost. Only 4 is left. 2, which is which you can see in the form of runoff. Okay. So can you tell me what is the runoff coefficient here? Can you tell me? Kindly comment everyone. Kindly comment everyone. What is the runoff coefficient here? So runoff coefficient will be what? Runoff upon rainfall. Okay. Runoff coefficient will be what? Runoff coefficient is nothing but runoff upon rainfall. Yes or no? 4 upon 10, it's nothing but 0.4. Very good, Sushil, very good. I hope this is clear to you. Yes or no? Perfect. Yes, perfect. So 0.4 is the runoff coefficient here. Okay, see, sometimes sometimes what happens, you need to make a note here. Sometimes what happens, sometimes let us assume we have a catchment area. Okay, sir. So we need to understand we have a catchment area. But you have to understand that runoff will not be same throughout the catchment area. Why? Sir, why runoff is not same throughout the catchment area? Can you tell me that? Yes, listen very carefully. See, in this entire catchment area, you need to understand that some portion of land will be covered by grass, some portion of land will be covered by roads, some portion of land will be having some different kind of land use. See, land use pattern varies. In some places you will see forests are there, in some places you will see roads are there, in some places you will see buildings are there. So you need to understand, when you have a huge catchment area, let us say huge catchment area, if you are talking about, let us take example of 5,000 hectare. Okay, let us assume that this catchment area is very huge and it is having an area of 5,000 hectares. It's a huge area. Sir, in this entire catchment area, you must appreciate the fact that in this entire catchment area, not all the area will be having the same land use pattern. Yes or no? The entire catchment area will not be having the same land use pattern. In some places you will see different land masses there, in some places you will see forest areas there, in some places you will see fallow land is there, in some places you will see pasture land is there. So different areas will be there, and you must appreciate that in different areas, it will be having different runoff coefficients. Different areas will be having different runoff coefficients. Yes or no? Understood, sir. So let us take an example. Let us assume that this first area is having runoff coefficient as C1. Let us assume that this second area is having runoff coefficient as C2. Third area is having runoff coefficient. See, why they are having different runoff coefficients? Because the land use pattern is different. You must appreciate the fact that in road area, wherever road construction is there, their runoff is more. And wherever there is, you can say, barren land, in that portion, infiltration will be more and you will see less runoff is there, because most of the water will drain into the ground, will go into the ground, or you can say simply it will infiltrate. Yes or no? Yes or no? So wherever you have more development, or you can say more amount of concreting is there, or simply you can say more road formation is there, there you will see that runoff is more. Okay, so obviously different land use pattern will be having different runoff coefficients. So let us take an example. So if in questions they will say, if in some question they will say that we have a huge catchment area, and in that catchment area different areas have different runoff coefficients. Let us say it is having area A1, it is having area A2. Just assume it is having area A3 and it is having area A4. So what will be the average runoff coefficient? What will be the average runoff coefficient? Can you tell me? So average runoff coefficient will be what? C1A1, C2A2 like that. C1A1, C2A2, C3A3 and so on so forth like that. Okay. C1A1, C2A2 like this, divided by the total area. Divided by the total area. This will be your average runoff coefficient. This you have to remember. Okay, this is important. Okay, this is important. This you need to remember. So what is my average runoff coefficient, or you can say equivalent? See, sometimes this is also called as equivalent runoff coefficient. Let me write here. Sometimes this is also called as equivalent runoff coefficients. So this will be your equivalent, or you can say average runoff coefficient for the entire catchment area. For this entire catchment area, if you want to replace this entire catchment area by a single runoff coefficient, that will be C average or C equivalent. Okay, sometimes we call it as C equivalent also. So both are one and the same. No need to worry about that. Okay, questions have been framed from this in examinations. Are you ready to solve one question? See, because in this lecture only I will give you the concept, and will also make you to practice some questions also. Okay, so are you able to? Yes, if buildings or you can say roads are there, runoff coefficient will increase. See, we'll discuss that concept also. So let us solve one or two questions so that you are able to understand this runoff thing thoroughly. Okay, so let us solve one question here. Okay, let us solve one very beautiful question here so that you are able to understand this runoff coefficient thing. See, one doubt is there. One boy is asking that, sir, when we will increase buildings, okay, when I will increase roads, how runoff is increasing, that you need to understand. Okay, see, we have not discussed water budget right now. In the next slide we will discuss water budget, but before moving to water budget, we will first solve a question. When I will discuss the water budget, this entire concept will be very clear to you. Okay, like where more runoff is there and where less runoff is there, we'll also solve some questions, so no need to worry about that. Okay, so first move on to first let's solve one beautiful question of average runoff coefficient. Okay, so this is a very beautiful question. Can you see in this question we have a catchment area of 120 kilometer square? It's a huge area. It's a huge catchment area. Yes or no? 120 kilometer square is not a small catchment area. For sure, this is not a very small catchment area. And you can see that in this catchment area we have three zones, namely A, B, and C. And area is 61, 39, and 20 kilometer square. Area is given to you. And the annual runoff in each of the corresponding areas are also given to you. Yes or no? Average areas, or you can say average runoff in annually, yearly, on yearly basis is given to you. Yes or no? So what you need to find, you have to find the annual runoff. What will be the annual runoff? Can you tell me? Can you solve this on your own? Can you solve this thing? See, it's very simple. You have to simply apply the same formula only. Nothing else you have to do. Take out your calculator and try to solve it. I will also help you out. So simply what we have to do, see, sir, you told us if I want to find average runoff, what I have to do, or you can say equivalent runoff. Sir, you have already told me that I have to do C1A1, C2A2. Already I have told you this. Already I have told you this thing. Upon the total area A1, A2 plus A3. Yes or no? Sir, one thing I haven't understood, sir, in place of C, you are writing R. This I am unable to understand. Can you clarify this concept? Yes, I will very simply clarify this. This is very simple. You need to understand. See, C is what? C is what? Runoff upon rainfall. Yes or no? This is R. See, in place of C, you can also write R. Why? Sir, because C is proportional to runoff. If I am writing C1A1, you can also write R1A1. Yes or no? They are one and the same. See, runoff coefficient is nothing but the fraction of total rainfall. Yes or no? It is fraction, 40%, 50%, like that. And if you are writing runoff, that is also same. Yes or no? So you can also write C1A1, because see, in place of C1, you can write R1 upon total runoff, total rainfall, sorry. So if C1 was there, C1 can be written as R1 upon total rainfall. So this P thing will get cancelled. Yes or no? So it is very simple. I hope you have understood this. So C and runoff are proportional, so we can write this. So one boy has also solved this question. So runoff in the first area A is what? 52 centimeters multiplied by area, which is nothing but 61 kilometers square, plus R2A2 42 into 39, multiply 42 by 39. Third one is 32 into 20. Yes or no? Third one is 32 into 20. Yes or no? Simple. Divide by total area. Total area is this much. 61 plus 39 plus 20. Simple. Okay. So when you will solve, see, also you need to understand the units, because see, you have to make sure that units are compatible, because in examination you have to answer your questions in appropriate units. Okay, so if I'm talking of denominator, sorry, numerator, runoff is in centimeter, area is in kilometer square. So in numerator the unit is centimeter kilometer square, and in denominator we have only area. In denominator we have only area, which is kilometer square. So this kilometer square thing will get cancelled with kilometer square, and you will be left only with centimeter part. Yes or no? You will be left only with centimeter part. So if you'll solve it, yes, Sushil is getting the right answer here. 45.416 is the absolutely correct answer. 45.416, or you can simply round it off to 45.4. Unit will be what? Centimeter. Yes or no? Absolutely correct. So this type of question, when it will be framed in exam, you can easily answer them. Yes or no? Very simple. 45.4. So this is the you can say this is the solution here. So this is your annual runoff, or you can say equivalent runoff in this entire catchment area. Okay, some portion is having this much of runoff, some portion is having this much of runoff, some portion is having this much of runoff. But if I'm talking of entire catchment area, if I'm talking of entire catchment area, what is the total runoff? If I'm talking about entire catchment area, the average runoff is 45.4. So I hope this is clear to you. Yes or no? This part is fully clear to you? Okay, fully clear? Kindly comment yes or no, so that I'm able to understand that you are fully connected with the class, you are participating, and all the concepts are getting drilled into your minds. Okay, so kindly comment yes or no, then we'll solve one more question. See, question practicing is very, very important. Why? See, I have also secured a very good rank in GATE. The best GATE rank which I have secured is 55. Okay, so why I am telling you about practicing questions? Because the rank which I have secured, okay, I have also cracked many other exams also. I just want to make sure that you are practicing hell lot of questions. Why? Because questions will be asked in exams. So if you are not practicing questions properly, uh, you will get stuck. Speed will not be there, accuracy will not be there. Okay, if you want to get a perfect balance between speed and accuracy, you need to practice and practice more and more questions. That's why I will make sure that in this hydrology lectures, okay, in these lectures I will make sure that you are getting proper practice. Okay, be it in class or be it in the form of DPP, so that you practice more questions and you are more comfortable in the subject, okay, or in the each and every corresponding topic. Yes or no? Okay, so now we'll proceed to this question. This is also another brilliant question. Okay, let us try to solve this one. Okay, let us try to solve this question. So what this question is saying, a catchment area of 150 hectares. Okay sir, beautiful questions. We have a catchment area which is having a area of 150 hectares. Okay, so let us assume this is a catchment area or simply basin or sink. So this is sir area of 150 acres. It is receiving a rainfall of 10.5 centimeter, and that too in 90 minutes. 90 minutes simply means 1.5 hours. In 1.5 hours, 10.5 centimeter rainfall is happening. Okay, due to a storm. At the outlet of catchment, the ephemeral stream experienced a runoff lasting for 10 hours with an average discharge of 1.5 meter cube per second. Sir, what is the meaning of this line? What is the meaning of this line? Ephemeral stream is experiencing a discharge of this much, which is lasting for 10 hours. What is the meaning of this line? You need to understand, after your rainfall, see, first let me tell you the meaning of ephemeral stream. See, that I will tell you also later. But ephemeral stream you need to understand right now because it is given in the question. Ephemeral stream is a kind of stream which experiences runoff, which experiences flow or discharge only when rainfall is there. Only when rainfall is there. When no rainfall is there, in that stream you will see no water is there. Let us take an example that see, this is an area of 150 hectares, and in the central part we have a stream, but this stream has no water. This stream has sir no water. It is completely dry. It is completely dry, sir. Water will only flow in this stream. Water will flow in only when rainfall is there. Only water will flow in this stream only after rainfall is there. So now for 1.5 hours rainfall is there, and sir, what I have witnessed that at the outlet, see, this is the end point because all the water will join this stream. all the water after rainfall will join this streams, okay, and ultimately water will flow down and will reach join the main stream, yes or no? And sir, what happened at the outlet? Sir, this is the outlet point. Sir, this is the outlet point. At outlet, sir, I was standing there and I have seen that this stream is simply evaluate the volume of runoff. If I simply want to evaluate the volume of runoff, volume is nothing but discharge into time, yes or no? See, 1.5 meter cube water is flowing every second after rainfall. See in this central stream only water has you can say water has come only after rainfall, so that is runoff only, okay. Whatever water has come from you can say over the land, or you can say in the form of subsurface flow or interflow, okay, that is nothing but your runoff only, yes or no? So how much total water? So 1.5 meter cube water is being drained every second. So for 10 hours, if I'm talking of 10 hours, you all know that in every hour we have 60 minutes. In every hour, if I'm converting this 10 hour into seconds, in every hour we have 60 minutes and every minute we have 60 seconds, yes or no? So total how many seconds we have? 3600 seconds, okay. If you multiply this, 3600 seconds are there in every hour, you all know this. So simply multiply this, how much water you can say is being drained by this ephemeral stream. Ephemeral stream is a stream in which water is there only after rainfall, otherwise it is completely dry. Otherwise it is completely dry, okay sir. So let me calculate this. Can you tell me how much we are getting here? See, this is 36 and it will be 54 if I'm not mistaken. 36 into 1.5 is 54 and we have 3 zeros, so I think the answer is 54,000 meter cube. If I'm not mistaken, the answer is 54,000. Can you comment? Yes, perfect. Okay, so 54,000 meter cube is the total volume of runoff. Now next thing which we want to evaluate is how much is the total volume of rainfall. How much is the total volume of rainfall? Okay, so how much is the total volume of rainfall? Can you tell that? So rainfall, if I want to evaluate, see in this question it is saying, beautifully it is saying that 10.5 centimeter rainfall is happening, and that too in 90 minutes. How much? 10.5 centimeter. And the area is how much? Area is 150 hectares. See, if I want to evaluate the volume, volume is nothing but area into depth. Area is how much? See, area into depth, if you will do, you will get the total volume. Okay sir, this is very simple. Now what is the area? Sir, area is 150 hectares. 150 hectare, and you all know that 1 hectare is nothing. 1 hectare is nothing but 10,000 meter square, or 10 power 4 meter square. This is very simple. This you have to remember. If you don't know this, note it down in your copies, okay. 150 hectare means 150 into 10 power 4 meter square, or simply 10,000 meter square. We have converted hectare into meter square, yes or no? Simple, simple, perfect. Now what is the depth of rainfall? Rainfall depth is 10.5 centimeter. 10.5 centimeter. Convert this 10.5 centimeter into meter. You all know that if I want to convert centimeter into meter, I have to divide it by 100. Simple. Okay sir, divided. Now how much we are getting here? How much volume of rainfall we are getting here? Can you tell me? Can you tell me? So if you will multiply this, I think 15 multiplied by 105. This will be somewhere around, I guess, 150, and this is 7.5, so it will be 157500, I think. Okay, 157500. If I'm not mistaken, this will be the answer. Can you kindly comment once? Perfect, Sushil, perfect. 157500 is the answer. Yes, you can simply multiply it. This is very simple. So you need to understand, out of this total rainfall, out of this total volume of rainfall, only 54,000 meter cube has converted, or you can say it is the portion which has converted into runoff. Sir, what has happened to the remaining water? Remaining water has, you can say the remaining water has been lost. Simply it has been lost. Okay. Now let us solve the two parts which they are asking. What they are saying, the very first part is saying, sir, find the volume of water which is not available for runoff. find the volume of water which is not available for runoff. So obviously we need to evaluate losses. Okay, we need to evaluate losses. Losses means from total precipitation or from total rainfall we have to subtract runoff. So can you find the losses? Can you find the volume water which is not available for runoff, which has simply infiltrated, or you can say which has transpired or evaporated, or be it any form? Okay, it has simply lost. So if I will subtract it, sir, I will get the answer. So out of this total rainfall, 54,000 has run off, and how much water has been lost? Simply subtract it. This is very simple. 1 lakh 3,000, I guess. 1 lakh 3,500. Okay, yes or no? I hope this is clear to you. You can simply subtract it. Yes, perfect. Now the second part is saying, so this is the volume of water which has been lost in the catchment area. Okay, sir, where it has gone? Sir, this water must have infiltrated into the soil. Some water must have evaporated. Some water must have transpired. Some water must have been lost in the form of varga. I have told you. Some water must have been filled in the depressions. Depression storage, I told you about depression storage. Some water must have been intercepted. See, these are all different kind of losses which I have already discussed yesterday. Yes or no? These are different kind of losses. Okay, so these are losses. Now at last we have to find what is runoff coefficient. Okay, so this is your you can say first part. Very simple. First part is very simple. Now we have to find, or simply you need to evaluate what is runoff coefficient. Can you find runoff coefficient on your own? Can you find it? See, runoff coefficient is nothing but C only. It is simply runoff upon rainfall. Runoff upon rainfall. So runoff we have already evaluated. Runoff we have already evaluated. How much? 54,000. Sir, very simple. Divided by 157,500, which is nothing but your total rainfall. So if you will divide this, see, both the units should be same. So how much value of C you are getting? 0.34. Perfect. 0.34 is the perfect answer. So I hope with this question you are able to understand the entire concept of runoff coefficient. Okay, I hope with this beautiful example the entire concept of runoff coefficient is fully clear to you. Okay, is this thing clear to you? Perfect. Now we'll move on to water budget equation. Okay, so this is the concept of your runoff coefficient. So we have solved two questions. I hope this entire numerical is fully clear to you. Okay, so we have solved it. Now we will discuss after this water budget equation. Okay, what is water budget equation, that we have to understand. Okay, now runoff thing is fully clear to you. You need to understand that out of total rainfall, some portion is lost and the remaining part runs off over the land, or you can say beneath the surface, and ultimately reaches your stream. Okay, ultimately reaches your stream. In that example we have discussed that all the water has drained into your ephemeral stream, in which only runoff water is there. Earlier there was no water. Okay, so that we have already discussed. Now we'll move on to water budget equation. Okay, see, water budget equation is very important. Water budget equation is very important from your gate point of view, because many questions have been framed in exams. We'll also solve today, only we'll solve one or two questions which are based on your water budget equation. Okay, very simple questions are there, but we need to understand this equation first. Okay, we need to understand this equation first. Very important equation you need to understand. See, water budget equation is also sometimes referred to as hydrological, or you can say hydrologic. Sometimes it is also referred to as hydrologic budget equation. Hydrologic budget equation. Hydrologic budget equation, or simply continuity equation, or simply continuity equation. Okay, both are one and the same. Be it continuity, you can call it as hydrologic budget, or you can simply call it as water budget. Okay, see, this equation is nothing but it is simply based on what? Sir, it is simply based on conservation of mass. See, this equation is very important. Please don't take it lightly. Questions can be framed directly from this equation in exams. Okay, so it is based on conservation of mass. So what this equation states, basically if you have certain area, okay, basically if you have a certain area, volume of water inflow, see volume of water inflow minus volume of water outflow minus volume of water outflow will be equal to change in storage, will be equal to what? Change in storage. This is the simple equation. This is the simple equation. Okay, this is your simple equation. Okay, very simple equation. Sir, you are saying that some water will go inside and some water will go out from the system. So let us assume we have a catchment area. Just try to understand. We will take it later also. See, if we have a system here, some water goes inside, some water goes outside. If inflow is more, you need to understand. See, three cases can be there. See, you need to understand that three cases can be there. What are the three cases, sir? See, the very first case is you can have more inflow. See, if more inflow is there and outflow is less, you will see that water is getting stored here. The level of water will increase. The level of water will increase, which means more water has deposited. Then you will say that delta S or change in storage is positive because more water is getting accumulated in the system. If inflow and outflow are same, the amount of water which is coming inside and the amount of water which is going out from the system are same, then you will see that there is no change in the level of water or in the storage. Okay, then I will say that net change in storage is 0. This is simple, very simple. But if inflow is less and outflow is more, somehow let us take an example in which evaporation is more, or you can say the water which is going outside from the system is more, then I will say that water starts to deplete, then the water level will go down, and I will say that change in storage is negative. Change in storage is negative. Yes or no? You can understand this? Okay, yes or no? So what happens? Inflow is less than your outflow. In that case, delta S becomes negative. So we have three cases here. Okay, water can either increase, decrease, or it can remain at the same level. Three cases are there. So this is your basic, you can say this is your basic water budget equation. See, you need to understand this change in storage is at three levels. Okay, this change in storage is at three levels. Okay, sir, what are the three levels at which this change in storage takes place? See, this change in storage can take place at surface, or it can take place at the level of soil, or it can take place in the at the level of ground. See, what is the meaning of SS? SS simply means storage at surface. Okay, or you can simply say surface water storage. Surface, see, some water comes into the system and gets stored in the lakes, gets stored in the rivers. So that is what? That is surface storage. That is surface water storage. Yes or no? Understood, sir? So whatever water is getting stored on the surface is nothing but your surface water storage. Some water gets stored in soil. You all know that after rainfall, some water is being absorbed by the soil and gets stored there in the voids. Yes or no? Yes, sir. So that is SM means soil moisture. Okay, that is nothing but soil moisture storage. Yes or no? That is nothing but soil moisture storage. So sir, you are simply saying some water gets stored in soil. Okay, and some water gets stored beneath the ground. Okay, in the ground level, groundwater level. That is nothing. G means groundwater storage. G means ground water storage. So simply you want to say that whenever water comes, it gets stored either on surface or in soil or in the groundwater or in the ground level. Okay, I hope this is clear to you. So water gets stored in these three levels. Okay, so this is nothing but storage part. This is nothing but storage part. See, if I want to make this water budget equation more clear, if I want to make this water budget equation more clear, I will take a very beautiful example of a catchment area. Okay, let me drink some water, then I will continue. So if you want to understand this, we will take an example of a catchment area and then we'll solve for both the levels. Okay, surface also and subsurface also. Okay, so what I'm saying here is, see, this is your basic water budget equation. Let me solve one thing here. So let us take a catchment area here. Let us take a beautiful catchment area here. Try to understand. Okay, so let us assume this is our catchment area. Okay, let us assume this is our catchment area. Okay, now you need to understand, we have to divide it into two parts. See, above this we have surface and below this level we have subsurface. You all know that above a certain level we have surface and below a certain level we have subsurface or ground. Yes or no? Understood, sir? So you are simply saying, sir, this is surface and this is subsurface. Okay, sir, this is clear to me. This is the catchment area. Now let me tell you all the forms of let me tell you all the forms in which water can come inside a system. Let me tell you all the forms in which the water can come inside a system. Let me talk about inflow and then I will also talk about outflow. See, water can go outside the system and water can come inside the system in many forms. So that forms we have to discuss. Understood, sir? So tell me, in how many forms water can come inside or it can go outside? See, the very first one which you all know is, let me draw it with a greening so that it is very, very clear to you. See, also you need to understand, that we have to uh, make, or you can say we need to calculate for both surface also. We have to evaluate at surface level also, and we have to evaluate it at subsurface level also. Okay, so at both levels we will evaluate. Okay, sir. Now tell me the different forms of water which are uh, different form of water which can come and which can go out from the system. So, sir, rainfall can come. I will name it precipitation P. That form of water is coming inside our system, inside our catchment area. Okay, so this is just a diagrammatic representation of a very small catchment area. Yes or no? Understood, sir? Now, sir, some water can come in the form of runoff. Let me call that R1. R1 is what? R1 is nothing but surface inflow. Okay, R1 is nothing but surface water inflow. Simple. Some water, sir, can also go outside the system. Okay, that is nothing but R2. What is R2? Sir, R2 is nothing but surface water outflow. See, this water can come from anywhere. Okay, see, let me take a small area, and in that small area some stream can come. Okay, water can come inside through stream in the form of runoff. So this is inflow, this is runoff inflow, and this is runoff outflow. Some water can go outside also in the form of runoff. Okay, it is not rainfall. Rainfall is different, this is different. Understood, sir? Now some water can get evaporated. Okay, some water can get evaporated out from the system, that we will abbreviate it as ES. ES means evaporation from the surface. So some water can come in the form of runoff, some water can go out in the form of runoff. Need to understand how many different forms are there which can come inside the system and which can go outside the system. Okay, so what else can be there? See, some water can get transpired. Okay, let us assume we have certain crops here. Okay, these are crops. So from these crops, sir, you will see that transpiration will happen. Water from the leaves will be discharged into the atmosphere. I will call it as TS. TS means transpiration from the surface. See, S here simply denotes surface. Yes or no? Understood. What else? Sir, some water can go from surface to subsurface. Let me call that at I. Let me call it as IF, infiltration. Yes or no? Some water can go inside from surface to subsurface. Yes or no? Understood, sir? I hope this is clear to you. I hope anything else which you can think of, anything else which you can think of is going anywhere else if we talk of surface. So I think only this much is there. Now let us talk of subsurface. Now let us talk of subsurface. So if I am talking of subsurface, you will see that some water can come inside. Okay, some water can come inside. That is nothing but G1. G1 means groundwater inflow. And some water can flow outside also from the ground. Some water can flow outside also. Okay, that is nothing but G2. G2 is groundwater outflow. This is groundwater inflow. This is groundwater outflow. Okay, so G1 and G2. We have G1 and G2. Yes or no? What else? See, some water can get evaporated out from the system. So water which is getting evaporated out from the system is nothing but EG. EG means evaporation from ground, evaporation from subsurface. Yes or no? Understood. Some water can get transpired off. Some water can get transpired off. That is nothing but TG. That is nothing but TG. TG means transpiration from ground. This is evaporation from ground. This is transpiration from ground. Simple. I don't think any other form is left here. So if I will apply water budget to both the systems, see, we have subsurface. See, I told you the basic equation is inflow minus outflow equal to delta S. Simple. Inflow minus outflow equal to delta S. So if I want to apply this water budget equation to the surface part only, to the topmost part only, now can you tell me how many components are coming inside? See, precipitation is coming inside. So firstly I will write the inflow parts only. Okay sir, precipitation is coming inside. What else is coming inside? R1 is coming inside. Okay sir, these are inflow only. These are inflow. Anything else which is coming inside? No. Now how many things are going outside from the system? Volume outflow, that we have to subtract. So you can see R2 is going out, ES is going out, TS is going out. Okay, you need to understand R2 is going out. Sir, evaporation from surface is going out, transpiration from surface is going out, and you can also see some water is going into the ground. That is infiltration. That is also going out. Yes or no? Nothing else is going out. So, sir, this is simply your inflow. This is simply inflow. This volume of water is coming inside the system, and this volume of water is going outside the system. Simple. Is equal to change in storage. This is equal to what? This is equal to change in storage. Change in storage in surface part only. Change in storage in surface part only. I have already told you that this change in storage can be in surface and also in ground. Yes or no? Okay. Okay, evaporation from ground, how it's possible? See, it's very simple. You all know that in ground, below the surface, you all know that water will be absorbed there, water will be there present. Yes or no? Some water gets evaporated. It's very simple. Okay, see, below the ground also evaporation takes place, and if some crops and weeds are there below the ground, they will transpire also. Yes or no? So simply it will get lost. Or if you are Sandeep, if you are doubting that evaporation and transpiration are not possible below the ground, you can keep it as 0. If you are doubting that evaporation from ground and transpiration are not possible below the ground, that can happen, or you can say it can happen in very, very negligible or least quantity, then you can keep it as 0. But here we are only discussing that in how many forms it is possible. It can be, you can say it can have some value, or it may not have some value. If it is not having any value, we can call it as 0. Okay, see, any of this quantity can be equated to 0 if it is not there. Okay Sandeep, I hope this is clear to you. We are only discussing how many different forms of you can say component, how many different forms or components can be there when we are talking of surface and subsurface. Okay, how many different forms of inflow and outflow can be there, we are discussing that only. Okay Sandeep, I hope this is clear to you. Understood? Okay, one boy is asking what is hydrology. Hydro means water, logy means study. It is simply study of water, nothing else. Okay, it's a huge planet, we have to manage water. Now if we talk of subsurface, can you tell me how many what things are coming inside? See, it is, this is coming, this is coming, so G1 and IF are coming, inside. This is nothing but inflow, and what things are going outside? Can you tell me? G2 is going outside, EG and TG are going outside. Okay, G2 is going outside, sir. EG is going outside, means evaporation from ground and transpiration from ground. All these things are going outside. So this is what? This is your outflow. So this is inflow, this is outflow, and this is what? Delta SG, which means change in storage in ground. Part. Okay, I hope this is clear to you. Perfect. Yes. Now if we will combine them, then what will happen? If I will combine, see, because you need to understand this is the total area, you need to understand that this is the total, this is your total catchment area. If you will combine them, see, simply add both these equations. See, this is your entire catchment area, you need to simply add it up. So if I will add them up, what will happen? See, we will write first P, add the left parts and then the right part. Okay, so we have P here, understood, sir. Then we have R2 in negative, we have R1 in positive. See, minus is plus, that's why I am writing minus R1 here, because minus is plus, this is plus. Okay, so we have written P. Let me cancel also. P I have written, R1 I have written, R2 I have written. Okay, R2 is in minus, R1 is in plus. Okay, now G2, you need to understand, we have G2 in minus. Okay, G2 is in minus and G1 is in plus. Yes or no? Let me subtract that also. Then you need to understand, when I'm adding this, we have evaporation from surface, we have evaporation from ground, both in minus. Both of them, evaporation from surface and evaporation from ground, both are in minus. Let me cancel that. Then we have transpiration part, both are in minus. Both the transpiration, be it from surface or ground, both are in minus. That I will also cancel. Also, we have minus IF here and we have plus IF here, so this will get cancelled here. So IF there is no need to write, equal to delta SS, or you can say simply change in storage on the surface plus change in storage in the ground. Okay, so this is your final equation. Yes or no? This is your final equation. We can call this equation your final water budget equation if I'm considering all the parts. Okay, so this is what? So this P means precipitation. Let me write the names for each and every term. What is P? Sir, P is precipitation. P is what? Precipitation. What is R2 minus R1? R2 minus R1 is what? Net runoff. It is nothing but net runoff. What is the meaning of net runoff? You need to understand. See, runoff means the portion of water which has run off out of the system. See, try to understand. Let us assume 100 water is coming from here and 150 water is going out from the system. So in all, how much water in net quantity has gone out of the system? You will say, sir, 50. Why? Because 150 is going out, 100 is coming inside. So overall 50 has gone out. That's why R2 is 150, R1 is 100. You will say that 50 has gone out from the system. That's why minus is there. Yes or no? I hope this is clear to you. In a similar fashion, water can go out from ground also. This is nothing but net groundwater flow. This is from surface, this is from subsurface. This is net groundwater flow. Yes or no? This is the net water which is going out of the system from ground part, from subsurface part. Okay, What is this? Sir, this is nothing but total evaporation. This is nothing but total evaporation. I hope this is very, very clear to you. It's very simple. This is nothing but total evaporation. Understood? What is this? Sir, this is total transpiration. This is what? This is total transpiration. Yes or no? This is total transpiration. And this is what? This is net change in storage, or you can say change in storage simply, in both the places, in surface and ground. This is simply or change in storage. So if I want to write the final equation, if I will write, see, this is English channel here. This is English channel, so obviously classes will run in English here. If you want to study in Hindi, you can follow Gate Wala MECE channel, where all the classes are running in Hindi only. Okay, separate channels are there, so there is no need to worry. We have English channel also, we have Hindi channel also. Okay, so this is your what? This is your final equation. So if I want to summarize this entire equation, I will write it like P minus net runoff, net groundwater flow, total evaporation, total transpiration equal to delta S. You need to remember this equation. This is very, very important. Okay, so what is my final equation? PRGET equal to delta S. Remember this equation, PRGET. Kindly comment everyone, PRGET. What is the final equation? Sir, PRGET. PRGET. Yes or no? PRGET is my final equation. PRGET equal to delta S is your final equation. Yes or no? Understood, sir. Now we need to simplify this equation. We have to simplify this equation. Okay, PRGET equal to delta S, this is my final equation. Yes or no? Now we have to understand one or two points. So for longer durations, if durations are very, very long, you need to understand that this delta S part will be 0. If duration is very, very long, sir, how come when we are having very, very long durations, this delta S will become 0? See, we will assume two things. We will assume two things, that my catchment area is very large. We will assume two things. Sir, what will assume? I will assume that we have very large catchment area. For large catchment areas, you need to understand. See, let me ask you one very beautiful question. In this case, delta G will be 0. But if you want to understand both of these concepts, sir, how delta G and how delta S are 0, or you are assuming, see, it will not be exactly 0, but we are assuming it to be 0 so that we can simplify our water budget equation. We have to simplify it. Okay, sir, how you are simplifying it? Sir, you are assuming, see, if you have a very large catchment area and if you have a small catchment area, tell me in which place you will see more change in groundwater. Let us say we have groundwater here. Okay, tell me where the groundwater fluctuation will be more. Let us say we have added some water here. Let us say we have added some water here. If you are adding water in both of the places, where the fluctuation will be more? Will the fluctuation be more in the first case, or will it be more in the second case? Where fluctuation will be more? Can you tell me? If I'm adding same volume of water to both the cases, be it 1 or be it 2, where you will see more fluctuation is there? Sir, it is very obvious that I will see more fluctuation will be there in the second one. Why? Because area is less. When area is less, the change in depth will be more, because we have to ensure that constant volume is there. Yes or no? Obviously, you see, both of you have understood that in second case fluctuation will be more. Yes or no? Yes, sir. So you can say that when we have a very large catchment area, when we have very huge catchment area, in that case the groundwater will not fluctuate much. The groundwater will not fluctuate much. That's why I am assuming it. That's why I am assuming it to be equal to 0. Delta G, I am assuming. See, it is not exactly 0. Obviously, some change will be there, but it can be assumed. It can be assumed as negligible, or it can be neglected, so that my equation is simplified. Understood, sir? This second assumption is fully clear to me. Now tell me the first one. See, this first one, for longer durations. See, you need to understand, if you are having a catchment area and in that we have water. See, if you will take 3 months duration, you all know that after 3 months monsoon season will be finished and summer season will start, winter will start. So when you will talk of season wise, after 3 or 4 months, you will see that huge change in water level will be there, because you all know that in monsoon season, water level will be very high. In monsoon season, water level will be very, very high. Yes or no? In monsoon season, water level will be very high. You all know this. Understood, sir? So in monsoon season, we have more water. But when you will go to summers, just after 6 months, you will see water level is very, very low. So fluctuation is very more. Fluctuation is very, uh, fluctuation is very, very high when we talk of 3 months, 6 months, like that. Okay, if we talk of 1 or 2, 3 or 6 months, you will see that fluctuation in water level is too much. But if I will talk of 5 years, if I will talk of 2 years, 5 years, 10 years, then you will see, if you talk of summer only, if you are talking of 2020 summer, and if you are talking after that, you will see 2030 summer, then after 5 or 10 years, you will see that change in water level is not there, because you are considering same seasons. So after a long time, you will see that rainfall has happened, summer season also passed, again rainfall has happened, again summer season, again rainfall, again summer season. So after 3 or 4 years, you will see that water level has again become constant. So when we consider long durations, 2 years, 3 years, 5 years, like that, then I will see that not much change is there in the water level. Not much change is there in the water level. That's why I'm considering delta S as 0. But yes, you know it that delta S is not 0 these days, because population is too much. Okay, so consumption is water very high. But in overall, if we are assuming population to be constant, if I'm talking of same area, then in longer durations you will see that delta is almost equal to 0. So if I'm making this as 0, and if I'm making this as 0, then what else we are left with? We are only left with two terms: precipitation minus losses. Let me write here. Okay, precipitation minus losses. Okay, be it evaporation loss, be it transpiration loss. Some losses we have not considered, like depression storage, all that. Okay, so precipitation minus loss is equal to what? Is equal to runoff. Delta R. Delta R is what? Net runoff. Delta R is what? Net runoff. So this is your final simplified equation. Yes or no? This is your final simplified equation. Very, very important. This is your final simplified equation. It's very, very important. You need to remember it. Okay, you need to remember this equation. Precipitation minus losses equals net runoff. Okay, so this equation is the simplified version, which you have to remember. Remember it like this: P minus L equal to R. Okay, this you have to remember. Simply, if I have to make sure that you understand this, I've already told you this thing. See, total precipitation P, loss is 6, and when you will subtract 6 from 10, only 4 will be left, which will go in the form of runoff. So now precipitation, after precipitation losses will be there. Sir, after precipitation, sir, losses will be there. And after losses, whatever water we are left with, that will run off over the surface, that will run off just below the surface, okay, and reach ultimately the central stream, which is at the lowest level or at the valley line of your entire catchment area. Yes or no? So the next chapters which we have to discuss are precipitation, losses, and runoff. This is chapter 2, precipitation. I already told you. After precipitation chapter, we'll understand all the losses which can happen from precipitation. That's your chapter 3. We have to understand evaporation, we have to understand transpiration, interception, depression storage, infiltration, percolation. These are all the different kind of losses that we have to understand. Okay, after which whatever water will be left off, that will go into form that will go in the form of runoff. Okay, I hope this is fully clear to you. So this is the final equation which you have to understand. Okay, so simply L here stands for losses. Losses like, see, I already told you, L means losses like evaporation, transpiration, and so on and so forth. Like evaporation, transpiration, etc. Okay, we have different losses that we'll discuss in chapter 3 only. No need to worry about that. So I hope this entire water budget part is clear to you. So you can remember this equation also. See, this is the full version. This is the full version of the basic equation, and this is what? Sir, this is the simplified version. This is the version which we have to remember if we want to solve questions in exam. In most of the questions you will see that this simplified equations has been asked. Okay, and from here only we will understand that out of total precipitation only some portion is converted into runoff, and from here you will get runoff upon rainfall ratio. Some portion of rainfall is converted into runoff after losses. Some portion of precipitation is abstracted and the remaining part is runoff. Okay, is this thing fully clear to you? Yes, perfect. Very good, Sandeep. Very good, Sandeep and Jyotish and Sushil. I hope this is clear to you. So this is your water budget. I hope water budget equation is fully clear to you. Remember it. Remember that it is simply based on conservation of mass. Okay, water can neither be created or nor it can be destroyed. Whatever water will go inside, okay, and whatever water will get, whatever water will go inside will get stored in the system until unless some water is going out of the system. Okay, so the net change inflow minus outflow will be nothing but your change in storage. Okay, so this is your basic water jet equation. I have make sure that you understand this very very clearly. Okay, so let us solve one very beautiful question. Of water jet equation. Let me see if you are able to solve this or not. Okay, let me see that if you are able to solve this water budget question. See, this is very very important question. Okay, it is based on water budget equation. Water budget equation is very important, from which you will find many questions have been framed in GATE examination, engineering service examination, be it state examination. Many questions have been framed. Okay, so be very very sincere and try to solve it. Okay, so we have one very simple question here. Okay, you can see a very simple question here. What this question is saying, we have a river reach. What is the meaning of river reach? Sir, river reach simply means a portion of river. Okay, let us take a portion of river. Let me draw it here. See, this is your river. In this water is flowing. Understood, sir? And we are taking a portion of it. Okay, we are interested in this portion only. Yes or no? So this is the portion. This is the portion of river in which we are interested. Understood, sir? This is the portion of river in which we are interested. Understood? Now what this question is saying, river reach means a portion of river. Understood? Now they are saying it has a flood wave. Flood wave means extreme flood. You all know when there is excess flow in the river, because after rainfall you will see flood wave will pass. Okay, so now this flood wave is passing through this river reach. That means immediate wave has been, you can say a flood wave is passing from this section. Obviously the flow will increase. Now at any given instant, the storage of water in reach was estimated as 15.5 hectare meter. It simply means initial storage, the water level. See, the total water here at any given instant initially, okay, initial storage is given to me as 15.5 hectare meter. Hectare means 10 power 4 meter square, multiplied by meter is meter cube. So this is nothing but volume only. So initially, before flood wave has passed, it has, this portion has 15.5 hectare meter volume of water. Understood, sir? This line is fully clear to me. Now what would be the storage in the reach after an interval of 3 hours? See, after 3 hours, now what is the total time? You all know that after 3 hours, when flood wave will pass, you need to appreciate the fact that when flood wave will pass, obviously water level will go high, water level will increase. Yes or no? Sir, after flood wave has passed, water level will increase and you will see that more water has been stored there. Okay, sir? After 3 hours, if average inflow and outflow is given to me as this much, so average inflow is given to me as how much? Sir, average inflow is given to me as 14.2. You can read it out from here. 14.2 meter cube per second, which simply means every second 14.2 meter cube per second water is going inside this river reach system. Yes or no? Sir, 14.2 meter cube per second water is going inside the system. Yes, sir. And how much water is coming out? How much water is coming out from the system? Sir, only 10.6 meter cube water is coming out from the system every second. Now what will happen after 3 hours? Can you tell me? After 3 hours, can you tell me water will increase or decrease, or what will happen? See, they are simply asking what will happen after 3 hours. So obviously after 3 hours we will have a final storage which will be more. Sir, why it will be more? Because inflow is more and outflow is less. If inflow is more, see, whenever flood is there, flood means more water comes inside the system and less water leaves. You all know what flood is. In flood, excess flow, or you can say a surplus flow, is there, where you will see that more water gets stored in the system. Yes or no? Yes. Now, can you evaluate exactly how much? Can you evaluate exactly how much volume of water will be stored? How much will be the increment in storage? Can you evaluate it? Sir, it is very simple. Simply, we have to apply water budget equation. See, this part is very, very simple. If you want to solve such type of questions, what you have to do, you have to simply apply water budget equation in this portion. So in this river reach, in this river reach system, I will apply water budget equation simply, or quantity equation, or you can say water budget hydrological equation, any equation you can call it as. See, inflow minus outflow equal to delta S. See, all these things are in terms of volume. All these things are in terms of volume. Yes or no? Understood, sir? So how much water is going inside the system every second? Can you tell me? Sir, 14.2 meter cube water is going inside the system every second. Now we have to multiply this discharge by time. If I want to evaluate volume, I have to multiply this discharge by time. What is the time given here? 3 hours. See, if 14.2 meter cube water is going inside the system every second, then in 3 hours how much water will go inside? Can you tell me? Sir, in 3 hours, every hour has 60 minutes and every minute has 60 seconds. So this is the total amount of volume which is going inside the system. This is inflow. This much meter cube. This much meter cube. Yes or no? And what is the outflow? Sir, outflow is what? 10.6 meter cube per second water is going out of the system. And in 3 hours, sir, in 3 hours I will see that 3 into 3600 water will leave the system. Yes or no? Yes or no? Tell me. Is it simple? So you will simply multiply and get it as how much? Yes, you are saying it absolutely correct. You are giving the answer also. So delta S will be what? When you will solve this, when you subtract it, the delta S, you are getting it as 919,193,880 meter cube. I guess you are getting this answer. Now this delta S is nothing. This delta S is nothing but final storage minus initial storage. Yes or no? If you will convert this delta S into hectare meter, you have to divide it by, you all know that 1 hectare is nothing but 10 power 4 meter square. Simply divide this by 10,000. So I will get it as 19.388 hectare meter. Because when you will divide it by 10 power 4 meter square will get cancelled. Only meter will be left here. Only meter will be left here. Okay. So if you will convert this volume into hectare meter, you will divide by 10 power 4 is equal to final storage minus initial storage. Initial storage is given to me as 15.55. Initial storage is given to me as 15.55 hectare meter. So how much is the final storage? So final storage is what? 19.388 minus 15.5. 19.388 minus 15.5. Tell me how much is your final storage? Okay, final storage is final storage is 19.388 only. Okay, wait a second. So wait a second. So this is final storage. Wait a second. We have to subtract this to get the delta S. Okay, you are solving it correctly. Yes, this is 38880. Sorry, this is 38880. Change is 38880. Change is 38880 divided by 10 power 4. You will get it as 3.888. Okay. So final storage will be what? 15.55 plus 5 plus 3.888. 3.888. You will get it as 19. Okay. Now we have reached the final answer, 19.388. Okay. Yes. Delta S is 38888. Okay, I read your comments. That's why I wrote 19.8, but delta S is 38880. Okay, so this is what 19.388 hectare meter. So such type of question I hope you can solve in the exams. Okay, such type of questions are basically asked in exams. I will also give you one homework question. Okay, I will also give you one homework question which you have to solve on your own. Yes or no? Yes. So final storage will be, so sir, simply you are saying the initial level, initially how much water is present here? Sir, initially 15.5 hectare meter water is there, but after your flood wave has passed, after 3 hours, sir, what I will see, after 3 hours, the total level of water which is there, the total level of water is 19.388. Yes or no? After 3 hours, how much water is there, sir? 19.38. So such type of questions you can easily solve. I hope this is very very clear to you. So sir, simply we have applied what? Sir, simply we have applied this basic equation, water jet equation. Okay, see, let me discuss one more question, okay, that you can solve from home also. Let's just discuss what this question is asking, that you can solve from your own, on your own. See, in this question it is saying a lake had a surface elevation of 103.2. so this is a lake which has a surface elevation of 103.2 meter. Okay, this question is saying you have to solve this on your own. I'm just giving you hint, and tomorrow I will see who has solved this question. So this is a level. This is a level which is being measured from any datum. Okay, now it is saying in this at the beginning of some month, let us take June month in which 30 days are there. Okay, we will basically assume 30 days month. In that month, average inflow and outflow are given to you. So inflow outflow is given to you. You can see inflow is given to me as 6 meter cube per second. Outflow is given to me as 6.5 meter cube per second. Rainfall received in that month, rainfall is 145 mm. Evaporation from lake surface. See, in that entire month, how much evaporation is there? Sir, evaporation is 6.1 centimeter. Lake surface area is given to me as 5000 hectare. Area of lake is given to me as 5000 hectare. Now, what is the surface elevation at the end of the month? So simply you have to evaluate the level after 1 month. You all know that in 1 month we have certain amount of time. In 1 month you can evaluate the number of seconds, and now you will apply the basic water budget equation. After this you will apply the basic water budget equation, inflow minus outflow equal to delta S. Okay, but one thing which you have to make sure, inflow is what? See, this is coming, this is coming, precipitation and this both are coming. See, inflow is in discharge, so you have to multiply this I with delta T. Delta T means 1 month. In 1 month how many seconds are there, that you can evaluate. Multiply it by 6 meter cube per second. Also precipitation is coming. Precipitation you have to multiply by area, because this is in depth. You have to convert this depth into meter multiplied by area. So this is the total amount of water which is coming inside the system from precipitation, and from inflow part. Okay, this is the total amount of volume of water which is coming inside, and the total amount of water which is going outside the system is what? O into delta T. Multiply the discharge by total 1 month time. Also evaporation, multiply this evaporation by area, and evaluate the change in storage. This change in storage will be in meters, meter cube. This change in storage, see, let me tell you the values. This is 6 meter cube per second. This is 1 month. 1 month is having 30 days. 1 day is having 24 hours. 24 into 60 into 60. Total seconds you will get. This is delta T. Similarly, this is delta T. This O is 6.5. P is 145 mm converted into meter divided by 1000. Area is 5000 hectare converted into meter square. Similarly, you can write this and you will get delta S. At the end, you have to evaluate change in elevation. So change in elevation is what? See, this is the change in volume. Divide this change in volume by the area, so that you get the change in elevation. Okay, if you are getting this change in elevation as positive, it will simply mean that level of water has increased. If you are getting this change in elevation as negative, then it simply means that it has decreased. Okay, so like this you can evaluate this question. I hope you can solve it. Okay, I hope you can solve this. So tomorrow I just want to know from you all that whether the level of water after 1 month has increased or decreased, or exactly by how much. So final level you have to find. Okay, I hope this is clear to you. Okay, so we will end our lecture here, and you can evaluate this question. Okay, so we will end it. So in basically in today's class we have covered the basic water budget equation. Okay, so we'll catch up tomorrow, not tomorrow, on Monday. Okay, your classes in these lectures will run only from your Monday to Friday. Okay, so we'll catch up on Monday at 10 p.m. sharp, where we will discuss the next chapter. We'll start the next chapter, which is your precipitation. Okay, so do solve this question, also solve all the DPPs, and if possible try to solve all the previous questions. Okay, so stay blessed. Thank you. Take care, everyone.